Alright, 9.2 video notes, properties of parallelograms. So we're going to spend the next 3 or 4 sections basically focusing on quadrilaterals because there's so many of them. We have parallelograms, rectangles, rhombuses, squares, trapezoids, and they all have different properties. And I'm going to go through in class, kind of build a hierarchy for you. But today we're going to focus on parallelogram because that's like the basic one that a lot of other shapes have properties similar to the parallelogram. So we're going to start off doing a definition and then just talk about properties or theorems, and then at the end we'll solve some questions using some algebra and some questions with just numbers. Alright, so a parallelogram is a quadrilateral, and by definition all you have to be a parallelogram is you have to have both pairs of opposite sides parallel. So that's the formal definition of a parallelogram. Parallelogram has both pair of opposite sides parallel. So in my picture, I get the markings here, and that basically tells me I know for sure that it's a parallelogram. Now there's a whole bunch of other properties that come with this, most of them focusing on parallel lines, because remember, when you have a set of parallel lines and then you have a transversal, so kind of picture these are my parallel lines, and then picture this being a transversal cutting across, all right? And picture this one as being a transversal cutting across. Well, now we have a lot of properties about angles that we know have to be true. You know, you have corresponding angles here going to match. You have alternate exterior, alternate interior, same side interior. So there's going to be a lot of properties that fall out because of parallel lines. So let's go down, let's kind of start hammering these, and just going to kind of talk about them real quick, and then we'll use them when we solve the problems. The next thing we need to know is about opposite sides. So opposite sides are going to be congruent in a parallelogram. So it's kind of similar to a rectangle. So the top matches the bottom, they're the exact same length, and the left matches the right, they're the exact same length. I almost think of it as like a rectangle that somebody just kind of shoved on and kind of made it go over so it doesn't have its 90-degree angles anymore. That's basically what's happening here. Now, so there's a theorem that says, you know, if a quadrilateral is a parallelogram, then it has opposite sides congruent. Well, the converse is also true. If both pairs of opposite sides are congruent, I also know it's a parallelogram. So you could kind of highlight that saying, if you have both opposite sides congruent, then it's a parallelogram, and vice versa. It goes both directions. All right. All right, moving on to the next property. The next property deals with opposite angles. So we were just talking about opposite sides. Now we have opposite angles. And the theorem says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So that's another feature. Opposite angles are equal. So opposite would be like kitty corner. So this angle and this angle are the exact same amount of degrees, and this one would match up. So typically you have two obtuse angles and two acute angles. And then the converse is also true. So moving on down. Diagonals, there's a feature about the diagonals here. So in a parallelogram, a diagonal would be cutting across. So I'm going to do like a blue diagonal, and then I'm going to show you a red diagonal. Now these diagonals are not the same length. The blue one is definitely longer than the red one, and I could really exaggerate this if I wanted to, and I could kind of, you know, draw a parallelogram that's got a really strong slant to it, and that would kind of highlight even more that this rectangle or this diagonal here would be much further than the short one. So the diagonals are not equal. However, the key thing is they bisect each other, aka they chop each other in half. Or you could also say they cross at each other's midpoints. So they basically cross right there in the middle. So what that tells me is that this blue piece is equal to this blue piece, and this red piece matches that red piece. So they both chop each other in half. And that property, all these properties are shared by squares and rectangles and rhombuses as well. All right, consecutive angles. So let's just talk a little bit about consecutive angles. Consecutive angles are two angles that are adjacent to each other or right next to each other. So in this one we'd be talking about, consecutive angles would be X and Y. So X and Y are consecutive angles. Now they're not equal to each other, okay? But we do know that they are supplementary. So we know that X plus Y has to equal 180. And that kind of comes from the fact that same side interior angles, when you have parallel lines and you cut it with a transversal, we refer to these guys, him and him, as same side inside, same side interior, and they always are going to add up to 180 degrees. So that's another fact. You actually use that one quite a bit. That one's pretty important. And then you kind of have this other way here at the end to prove that if you can get just one pair of sides to both be congruent and parallel, then you could prove it's a parallelogram. We're not going to get too much into proving that things are parallelogram, but that could be useful if you ever had to do that proof. I'd rather you focus on the properties. That's what's you're going to see more on standardized testing. All right, so here's kind of a little breakdown of everything that we've kind of put together from up above. These are all the ways that I could prove it. Both sides parallel, that's the definition. Opposite sides congruent, opposite angles congruent. One pair of sides that does both congruent and parallel, and then the diagonals bisecting each other. So when you look at it, basically you have one of sides, you have two talking about sides, you have this one is talking about angles, you have this one here is both sides and being congruent and parallel, and then the one at the bottom is focusing on the diags. So that's the one people tend to forget about, is that the diagonals are bisecting each other because there's such a big focus here on sides. All right, let's jump into some problems here and see if we can make some sense of this. So number one says solve for X and Y. So I have this diagram here and trying to solve for X and Y. So first let's go after X. Well, when I find the X, it's right here, 2X. Well, this angle and this angle 50 must be equal to each other. Okay, angle J has to be congruent to angle L because that's a property of a parallelogram. So I should be able to substitute the values in there and solve for it. And it looks like X has got to be 25. So I use the angle property there on that one. Now, the Y, since it's outside here, Y plus 3, that represents this side. And I know that opposite sides are equal, so I know that Y plus 3 has to equal 18. And when I solve that equation and I minus the 3 from both sides, I find out that Y has to be equal to 16. So I used two different properties there. I used the fact that opposite angles are congruent, and then I also used the fact that opposite sides are congruent. All right, example 2, part of the extending lamp is a parallelogram. What's a little skinny one up there? Find the measure of angle BCD if ADC, all right, so I'm going to tell you right away, I don't like this drawing. So when I don't like a drawing, I redraw it myself. So I'm going to redraw this thing bigger, and hopefully it'll make a little bit more sense to me. I would always do that on any test or any homework. If you don't like the picture, redraw it. Make it a little more user-friendly. So it says find BCD. So we're actually trying to find this green angle right here. Find how many degrees that is. If ADC, so ADC is this angle right here. That angle is twice BCD. All right. So angle ADC is twice as big. So I got to find they're twice as big. Now one other thing is, since this is a parallelogram, and these two angles, they're not opposite angles, they're consecutive angles, they're right next to each other. I know that they have to add up to 180. So let's just call this one, to show twice the measure, if I call this one X, that's what we're after. We're trying to find X. And if they tell me angle ADC is twice as big, I could represent that as 2X. So now I've guaranteed that this angle is twice the size of that angle. And then I use a property knowing that they have to add up to 180 degrees. So 2X plus 1X has to be 180 degrees because consecutive angles are supplementary. And now we just do a little algebra and we solve this. 3x is 180. Divide by 3, and we get x equals 60. And that should work out. Alright, moving right on down. Find the coordinates. So this wants an ordered pair. Coordinates mean I got to find, you know, an XY. I got to find the ordered pair of the intersection of the diagonals of LM and O. And so let's put these on here. So I have 1, 4. I have 7, 4, 3, 4, 5, 6, 7. So this is M, this is L. N is at 6, 0, and O is at 0, 0. So it looks like this is the parallelogram that we're talking about. And I got to figure out what is the coordinate, where do the diagonals cross at? So I know the diagonals bisect each other. So there's one diagonal right here, and there's one diagonal right here. Now my drawing, it's a little hard because you know, I'm just kind of sketching this. I'm not using any tools or any rulers. So where it crosses, I'm not exactly sure from the drawing. So basically what I need to do is I need to go back into chapter 1 and I need to find the midpoint of either one because it crosses the middle of both. Let's find the midpoint of segment OM. So a little bit of review from chapter 1. Whenever you want to find the midpoint, you write down the ends. So this is point O, and point M is at 7, 4. So we need to find the middle. Now there's two ways to do it. One way is pretty easy. Just find the middle of these two x's. You know, the middle of the x's here is 3.5. That's exactly halfway between 0 and 7. And then what's exactly halfway between 0 and 4? Well, that would be 2. And if I go to my drawing, you know, 1, 2, 3.5, up 2. So it looks like it should have crossed right here. So it looks like my sketch was just a little bit off. But I think that's a pretty good point. Now, the formal way to do it, you call this X and Y, and you call this X and Y, and this is number 1s, and these are the number 2s. And basically, we have to average the X, and we have to average the Y. So when you average the x's, you add the two x coordinates together and divide it by 2. And then you add the y coordinates together and divide it by 2. And you will also get 3.5, 2. Now I didn't show it, but we could have did the same thing for L to N, and that should have worked as well. Alright, number 4, what are the values of x and y to make sure it's a parallelogram? This one's kind of tricky. If you start on the wrong pair of sides, you're going to run into an issue. For instance, it is true that this blue side equals the blue side. So it is true that y equals x plus 7. The problem is you can't solve that equation because it has two unknowns and there's only one equation. So I'm going to have to focus on the other two sides. I'm going to have to focus on the fact that x plus 9 has to equal 2x plus 1 or minus 1. I can solve this one because there's only one x there. So let's go ahead and solve it. I'm going to subtract that x from both sides. Now I'm going to get rid of the minus 1. I'm going to add 1 to both sides. And I find out that x equals 10. So now I can go back up here to this top equation, and I can go ahead and finish this one, because y equals x plus 7, I now know what x is. X is 10. So it looks like y has to be 17. So just got to be kind of careful of what equation you use and whether or not you can actually solve it or not. Alright, let's scroll on down. So this one, it looks like they're focusing on the diagonals. And I know that diagonals bisect each other. So I know that this piece right here equals this piece right here. So this one's pretty straightforward. 5x minus 8 equals 3x. And I set that up because the diags bisect each other. They chop each other in half. So we solve this. There's a couple different ways. I'm actually going to subtract 5x from both sides to get all my x's over there. And I'm left with negative 8 equals negative 2x. And now if I divide both sides by negative 2, I find out x equals 4. And that's all they asked. They just said for what value of x. Now I could go back in and plug some stuff in and find it, but I don't think we really need to right now. Alright, for what values of x and y is this a parallelogram? So I'm kind of looking at the angles here. They're not talking about sides, they're talking about angles. And there's two basic angle properties. I know that opposite angles are equal or congruent. And then I know that consecutive angles add up to 180. So I think I'm going to start off with this opposite angle fact. I'm going to set up an equation. It doesn't matter which way I go, but I know that this angle and this angle are the same. So let's go 3x subtract 32 equals 2x. And I'm going to subtract 3x from both sides. And I get negative 32 equals negative 1x. Divide both sides by a negative 1 or times both sides by negative 1, whatever you want. And you get x equals 32. So basically I just used this fact to figure out what x is. Now if I wanted to, I could plug 32 in for x and find y using the consecutive, or I could just play the game again putting the y's equal. Maybe I'll do that. I'll just say, hey, you two have to be equal. So y plus 87 has to equal 4y. And I just do the exact same game. Take away y from both sides. That gives me 87 is 3y. Divide both sides by 3. And you will get y equals, what's that, 29. And let's be sure that's what they want for what values of x and y, so I don't have to plug it back in and find any measures. Now I could, and it should work out. If I wanted to, I could plug those values in. 4 times 29, that's 116, and 29 plus 87, that's also 116. So that one looks like it works. If I put 32 in, 2 times 32 is 64, and 3 32s, well, that's 96, take away 32, and that's 64, and it looks like it checks out. I have opposite angles are equal both ways, and then I also have the fact that consecutive angles add up to 180, so I know that life is good. I did it right. Alright, final question. Show that it is a parallelogram. Well, in order to show or in order to prove, in order to show or prove that it's a parallelogram, that was all those ways on the first page. So if I scroll up to right here, these are all the ways. So basically, I have to look through and I have to pick, not all of these, but just pick one. Pick one to go for. So can I show both sides are parallel? Well, if I want to do that, I'm going to have to use slope. Maybe I'll put this down here on the chart. So this is kind of an open-ended question that really you could kind of go however you wanted to. So I'm going to write this over here. Okay, so just pick one of these. First property is if I could show that AB is parallel to CD and AD is parallel to BC, that would be good. Okay, and the only way that I can do this one is if I look at slopes. Alright, so let's just do this real quick. The slope of AB is a positive line. It goes up 2, it rises 2, and it runs 5. So AB is 3/5. And CD down here also goes, I don't know why I put 3, it's actually 2. Screwed that up. Up 2/5. And down here, this one looks like it goes up 2/5. So those two are parallel, but I got to get both. I have to have both of them if I'm going to prove this. So now coming the other way, these slopes are negative. They're coming down, and it looks like they go down 3, right 3. So this guy's slope right here is down 3, right 3, and AD is going to do the same thing, down 3, right 3. So basically, I've just proven that that's a parallelogram because I showed that both pair of opposite sides are parallel. So that's what we did for this one. Both pair opposite sides parallel. Now, if you wanted to, you could be done. All right, that would be enough. You don't have to prove all these. But I'm just going to show you maybe one other way. If you wanted to do the distance formula or the Pythagorean theorem, you could actually prove that both pair of opposite sides. So if you wanted to prove both pair opposite sides are congruent or equal length, if you want to do that, you'd have to use the Pythagorean theorem or the distance formula. So if you like those and you're comfortable with those and you'd rather do that than slope, you could do that. I could prove that diagonals bisect. If I wanted to go that route, like we did in the above example, I could show that diagonals bisect. And for that one, I'd have to use the midpoint formula. And I'd have to show that they cross at the same midpoint for each other. I can't really do the opposite angles, so this is what you don't want to try this one. You don't want to do opposite angles equal or opposite angles, not opposite angles, consecutive angles. My eraser in there. Consecutive angles supplementary, because I don't have a protractor and I can't calculate those two to see if they add up to 180 degrees, and I can't see if the angles are equal. So on the coordinate plane, you really don't want to do angles. Okay, I can show parallel and I can show length, I can do diagonals, but you can't really do anything with angles, so don't use those. Alright, I know these were a little long, we're at a little over 20 minutes, but hopefully this will give you enough to be able to do the practice tomorrow and be successful. See ya!